Hello student, this is Mandeep Alexander, PGT physics teacher at LFS Gida. I am here again to explain about something about our practical which is in grade 11. Okay, this is one of the aim which I have written here for our practical, that we need to measure the diameter of a spherical oblique cylindrical body using vernier calipers. Okay, for different measurement if we come across, then we use different instruments. Similarly, if you want to measure the diameter, which is really a very significant diameter, it's not very minute diameter, okay, it is a very significant diameter. For example, if you go in a physics lab, then you will be given this type of a sphere, okay, this type of a sphere. So this has a significant diameter in it, okay, this has a significant diameter in it, okay. You can see this spherical ball which I am having. So for such type of the sphere, if you need to calculate the diameter, then you need us vernier calipers. But there is one more instrument apart from this. I just want to explain. For example, if you are having very thin wire with you and you want to measure the diameter of that wire, so in that case you will not get a very precise reading if you use the screw gauge. Okay. So in that case, if you use the vernier calipers, you will not get the very precise reading. So in that case, you will be using another instrument known as a screw gauge. Okay, so that we will be using in our next experiment. But in this experiment, what we will be using? We will be using vernier calipers. Here you can see the vernier caliper which I am having. This is a vernier caliper. It has two jaws. It has two jaws in it. Okay, this is the movable jaw. This is the movable jaw. You can see. Okay, with the help of our thumb, we can move this jaw to and fro. Okay, and this has two scales also. This has two scales also. This has two scales. You can see that there is one main scale which is on this bar. You can see the readings. You can see the readings of these scales. And apart from it, it has one more scale that is known as the vernier scale, which you can see on this movable jaw. This is the movable jaw. And this has one scale on it. Okay. And this scale is known as the vernier scale. So if you want to calculate the diameter of this spherical bob, so what you need to do, you just need to place this bob in between these jaws. Okay, like this you need to place this bob in between these two movable jaw like this. Okay, and after placing this, I just want to tell you something according to this maximized figure which I have drawn. This is the rough figure of a vernier calipers, and in this what we are using, we are placing a spherical bob in between these jaws. And I have just tightened the other movable jaw, and I have tightened this ball which is present inside this jaw, and now it has been fixed. Now let's see how to calculate the reading. So before calculating the reading, it is very important for a person, it is very important for an observer that he should know what is the least count of this instrument which we are using. Here we are using what? Here we are using the vernier calipers. Okay, here we are using, this is the vernier caliper which we are using. Okay, so this instrument, if it is a measuring instrument, then this should also have some least count in it. Okay, least count is nothing. Least count is simply the smallest measurable unit which our instrument can measure. So what is the smallest measurable unit of this instrument? Let's try to find out. If we observe the rough figure of vernier calipers, then what we can see, that in between the 0 to 1 scale, okay, in between the 0 to 1 scale, okay, then you can see the reading that from 0 to 1 there are different minute scales, okay, there are different minute units in between. So in between 0 to 1, in the main scale if we are talking about, okay, this is the main scale. And this is the vernier scale which I told you by showing the figure. Okay, this is the vernier scale. Okay, so in main scale if you see that, you can see in between 0 to 1 there are total 10 number of the divisions. Okay, there are small division you can see here. There are total 10 in number. But if we talk about this vernier scale, which is the scale, and the total number of the unit in this vernier scale are 10 in numbers. Okay, so here also there are 10 in numbers, and here also there are 10 in numbers. So what we do to calculate the least count? What is the practical way? We just write like this. Least count L dot C can be written as 1 upon this 10 number of the division which lies in between this main scale reading. Okay, so 10. And what else we need to divide? We again divide 110, which is the total number of the division in this vernier scale. Okay, So 10 into 10. This what we write. And this comes out to be how much? This comes out to be 1 upon 100, which is equal to 0.01 centimeter. And this is the practical way to calculate the least count of this vernier calipers. Now let us observe. Let us take a random value. For example, if we have placed this bob in between these two movable jaws and we tightened this with the help of our thumb. And now we have taken the reading and we removed this ball in the first step, okay, after taking the reading. But what else we need to do? What else we need to take precaution here? We just need to fix this jaw. We just need, there should be no variable change in this jaw while we remove this bob from this jaws. Okay, from these jaws, if we are removing the bob, then there should be no variation in the scale. Okay, it should be as in the case we have done our experiment. Okay, it should be like that only as we have done our experiment. It should not be changed. This jaw should not be changed. After fixing the bob and after removing this bob, this jaw should not be changed. And now we observe very closely. And now what we observe very closely that what is the value of this main scale and what is the value on this vernier scale. So for suppose that after taking reading we just take out this bob and we kept that jaws fixed regarding that bob and we observe the main scale reading in this case. So what we see, suppose that this main scale or this movable jaw has moved some distance or moved some scale across on the right hand side. And suppose that this 0 of the vernier scale, there should be a starting dash line in the vernier scale also, and the 0 of the vernier scale may be coinciding with some of the line on this main scale. Okay. For example, if it is coinciding with the third line after this one parameter on this vernier scale. For example, the 0 of the vernier scale, if we have taken the reading, is coinciding with the third parameter after this one curve. Okay, on this main scale. So we can easily count down here the main scale reading and it comes out to be near about 1.3. I am just taking the random value. Okay, so in the first step which we did, in which we are doing our observation, we are just writing it like this 1.3 centimeters in our main scale. Okay, and what else? What this vernier scale reading stands for? This is the main scale reading, and what will be the vernier scale reading in that case? So the vernier scale reading also has to be taken into account just to calculate the total scale reading of the diameter. Okay. So now what else we do? Just keeping the jaws fixed at that position only. What we do? We just matches the scale. We just match out the scale of the vernier caliper, that which scale or which line is matching perfectly in a straight way with the line which is on the main scale. Okay. For example, if this third line, okay, if this second line, 1, 2, if the second line is coinciding in a very straight manner with this main scale line, okay, if this second line of the vernier caliper is coinciding perfectly with the one of the line on the main scale, so what we do? We just simply write 2 on the vernier part and we just simply do the multiplication with the least count of the vernier scale. Okay. And now what the result comes out to be? It comes out to be 0.02. And for the total scale rating, this is the total scale rating, what we do? We add this main scale rating and vernier scale rating. Now according to our observation, the results come out to be how much? 1.30. Okay, sorry, 1.32. Comes out to be 1.32. Now suppose again we have taken that bob and again we place that bob in between these jaws and again we tighten this movable jaw, and after taking the reading we just remove this bob out of these jaws and we have just kept that jaws fixed. We have not changed that scale after taking the reading. Again I am following the same step. Now again what we have observed, the 0 supposed to be on the third line after this one scale. Okay, after this one count it lies on the third line of this main scale. Again what we have done? Again we are getting near about 1.3 value on the main scale. And in the next phase what we need to do? We need to see the vernier scale again. So in next scale now we are getting, just it may be due to some personal error, it may be just due to defect in our eyes. Now instead of observing the second line which was earlier we are observing, instead of getting the second line which earlier you were getting, that it seems to be coinciding parallelly with the main scale line. Now we are assuming that now it seems to be like that the third line of this vernier caliper is coinciding in a very straight way with the line of the main scale. Okay, now instead of assuming the second line, now it seems to be like that the third line of the vernier scale, okay, 1 2 3, the third line of the vernier scale is coinciding parallelly with the line of the main scale. So instead of writing 2, there may seems to be some slight variation, that comes out to be 3, and it will be multiplied similarly with the least count. Now what we will be getting? We will be getting this value. Now similarly this and this will be added to get the total rating. Okay, now we will be getting the total rating as 1.33. Similarly again we place this bob. Now there will be no variation in the main scale. If we are taking our reading perfectly, then there should be no variation in the main scale. Okay, this should be very clear because these are very significant scales. What we observe very slight difference. The slight difference can be observable in this vernier scale. Okay, because these are very minute scale. The slight difference may be observed just because of our defect in our eyes or just because of our carelessness. Okay, so again in the third step we are taking that similar bob and we again just placed in between these jaws and we tightened that jaws. And now again we are getting 1.3 count on the main scale because the 0 is coinciding with the 1.3 part of the main scale. That's why I have written 1.3. And now suppose that we are getting the fourth line of the vernier scale which lies completely in a straight way with the main scale line. Okay, now suppose this fourth line is coinciding directly with the main scale line. Okay, in a straight way, it seems to be parallel. Okay, so in that case the vernier scale reading comes out to be how much? 4 into 0.01 and it comes out to be 0.07. Now again this and this will get add and the result comes out to be 1.3. Okay, now you are having total 3 number of the observation according to your steps which you have done. And now just to get the actual value, that what is the actual value of the diameter, what you need to do? You simply take the mean of all the 3. Okay, now after taking the mean of all the 3, what you will be getting? You will be getting the actual diameter what you want to calculate. Diameter, if I denote it by d, then it will be 1.32 plus 1.33 plus 1.34 upon total number of the observation. This is how we can calculate the mean. Okay, and what you will get? You will get the approximate value of d near about 1.33 centimeter. This will be in centimeter. So this is the way in which you can calculate the diameter, whether you are being asked to calculate the diameter of a rod or whether you are being asked to calculate the diameter of a spherical bob. By using this figure, by using this instrument, that is the vernier caliper, you can easily calculate the diameter. And if someone asks you to calculate the radius also, then you just take the half of the diameter and you can finish it up. Okay, thank you.